Now that we've proved a few properties of quadrilaterals, we'll work on a few examples that use some of those properties. So let's prove that a quadrilaterals in which the diagonals are congruent and bisect each other, that it is a rectangle. All right, so the first thing I'll say, if you've got a quadrilateral in which the diagonals bisect each other, what you have is a parallelogram, because we found that that was one of the defining properties of a parallelogram. If the diagonals are bisectors of each other, then we know that ABCD, quadrilateral ABC, is a parallelogram because the diagonals bisect each other. All right, now what we need to do, I know that the opposite angles are congruent. I also know in a parallelogram that adjacent angles are supplementary. So if I can show that these angles, not only are they supplementary, but if I can show that they are congruent, then two angles that add up to 180 degrees that are congruent have to each be 90 degrees. So then I'll get for free that this object is a quadrilateral. So let's take a look at triangle ABD and triangle DCA. First of all, AB is congruent to DC because opposite sides in a parallelogram are congruent. So by opposite sides in a parallelogram, I also know that side AC and side BD are congruent because that was given. So this was sort of given information. And now AD, they share the side AD. So AD is congruent to itself. So therefore, by side, 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 triangle ABD is congruent to triangle DCA. So now that I have these triangles are congruent, I have that this angle here, BAD, the angle BAD, is congruent to this angle, CDA. And that's by corresponding parts of congruent triangles are congruent, CPCTC. So therefore, these two angles are supplementary and congruent, so they must be 90 degrees. All right, so therefore, ABCD is a parallelogram with a right angle. So quadrilateral ABCD is a parallelogram with a right angle. Therefore, it is a rectangle. Great. So just with a little bit of information, I can tell you, I can classify the shape. So let's move on to another property, and this one will come with definition. The median of a triangle is a segment joining the vertex to an opposite side that bisects the opposite side. So in our example here, I have a right triangle. So angle C here is a right angle. If you draw in the median, we want to show that the median length, CD here, is exactly half as long as the hypotenuse AB. So in order to show that, basically what I want to do is show that this length here is the same as this length and this length. And in order to do that, I'll use some properties that I know of with parallelograms and rectangles to construct a quadrilateral, show that it's a rectangle, and then the properties will just fall out. So first thing I'm going to do is I want to extend this median. So I'm going to measure the length here. And you don't have to do this with a construction. I just think it'll be fun to use a construction to show this property here. All right, so I'm going to extend this median so that it's exactly twice as long. And that'll construct for me another vertex. Let me call it E. Let me just draw in two more sides here. Basically what I'm doing is I'm constructing a parallelogram from this given information so that AB, which was the hypotenuse of the right triangle, is one diagonal, and then CE is another diagonal. Okay, so by the information that I was given, AD and BD are congruent to each other because CD is the median. So AD is congruent to DB. This was kind of given to us. And then we'll construct E so that CD is congruent to DE. Right? So I know that this length and this length are the same. All right, so now what I have is a quadrilateral in which the diagonals bisect each other. So quadrilateral ACBE is a quadrilateral whose diagonals bisect each other. Therefore, what we have here is a parallelogram. ACBE is a parallelogram. All right, because you have a parallelogram with a right angle, it is actually a rectangle, since the measure of angle C is 90 degrees. So it's a parallelogram with one right angle. Okay, and we know with rectangles, not only do the diagonals bisect each other, but the diagonals are congruent. So because these two diagonals are congruent, then this half should equal that half. And that should be the same as this half, CD to DE. So therefore, I know that side AD is congruent to side CD, which is congruent to side DB. So these are all the same length. So that tells me that the measure of side CD is actually half of the sum of these two sides, AD plus DB, which is half of the side AB. So therefore, the median is exactly half as long as the hypotenuse. Now, the homework in this section of the book might feel a little bit strange because we're dealing with a lot of geometry. So the homework here will have some constructions. So I would recommend definitely practice these constructions since you'll be tested on them. So there'll be constructions and a lot of justification. So it'll be like given some information, prove something like the triangles are congruent or prove what the measure of some angles are. So that's what's happening in this section of the homework. So make sure to take your time, ask lots of questions, attend office hours where I can help you work through these constructions.